Alright, so this is number 1 in the booklet that you got today. First thing I'm going to do is factor the numerator and denominator, so I get x minus 2, x plus 1, and then in the denominator it's x minus 1 squared, right? Because it's the same factor. So from here I'm going to answer all of these attributes. First off, the domain. So I look at the denominator, so I say that the domain is all x such that x cannot equal 1, because the 1 makes the denominator 0. This one has no holes because none of the factors cancel, so none, empty set. X-intercept, you look at the numerator and you ask yourself what makes the numerator 0. So remember, intercepts are points. X-intercepts are points, so you need to write it as an ordered pair, 2, 0, and negative 1, 0. Y-intercept, you can cover up the x's in the original function, right? Or you can replace all the x's with 0 in the factored one, but it's a lot easier to just cover up the x's in the original. So you get negative 2 over 1 when you cover up these 4 terms right here, so you're just left with these 2. So that gives you negative 1. So again, y-intercept is a point, so you should write it as an ordered pair. Vertical asymptote, you look at the domain or the denominator, whichever one, and you see that x is 1. Horizontal or slant, because this is powers equal, it's going to be a horizontal asymptote. When its powers equal, you look at the leading coefficient of both the numerator and denominator, so 1 over 1 is 1. Okay, and this is where I looked, right here and right here. Symmetry, replace all the x's with negative x, and we get no symmetry. It's not even, it's not odd, so it's not symmetric with the y-axis or with the origin, so we just put none or neither. It's either one. Okay, and so we're ready to graph. So intercepts first, x equals 1. Okay, y equals 1. Okay, and then I'm going to plot the points. So the points, the intercepts, so 2, 0, negative 1, 0, and 0, negative 2. Okay, so on the left side, now remember, the vertical asymptotes are the ones that divide the function into that many pieces. So because we have one vertical asymptote, we're going to have one piece of the graph on the left side and another piece of the graph on the right side of that asymptote. We already have 2 points right here and 1 point right here, so I know that my graph is going to go down here and it's going to go right here. So there's no need to pick any other x values. You have enough with what you have right now on the graph. So just remember, the graph goes towards the asymptotes. Okay, like this. And then the one on the right side, since I have that 2, 0, just graph towards the asymptote. And that's it. Alright, so number 2, again, first thing we do is factor whatever you can factor. So in this case, only the denominator, x plus 2, x minus 2. Okay, and with that, we know that the domain is going to be all x such that x cannot be plus or minus 2. Again, by looking at the denominator, those are the values that make the denominator 0. It has no holes because we have no common factors to cancel out, so no holes. X-intercept, because no real number makes the numerator 0. It has no x-intercept. For y-intercept, remember we cover up the x's in the original problem and the one that's not factored, so I would cover up these two, and so I'm left with 4 over negative 4, which is negative 1. Vertical asymptote is x equal negative 2, x equal 2. This one is powers equal, and so I'm looking for at the leading coefficient, so here and here. So that would be y equals 1. As for symmetry, when you replace the x with a negative x and simplify, you get the original function back. So this one's going to be an even function, so it's going to be symmetric with respect to the y-axis. Okay, so that's how this is helpful, because it gives you the symmetry. If it has symmetry, then you know it helps. So let's go ahead and plot what we have, draw what we have. Intercepts, the asymptotes first. So this one, x equals 2, x equals negative 2, and then y equals 1. Okay, and then we have, let's see, 1 intercept, the y-intercept, 0, negative 1. Okay, so with that in mind, I know the graph is never going to cross the x-axis, and I have a point at 0, negative 1, and I know that the graph is symmetric with respect to the y-axis. So then with that in mind, I know that the graph is going to go down this way, because it can't go up, right? It can't, there's no way it can go up. Now, I also know that the graph is going to go in this section up here and this section up here, but just to get a better idea of like where the point is going to go, just to see how steep your curve is going to be or how close it is going to be to the asymptotes, it's a good idea to find a point, to evaluate at one x value. So let's just say at 3. So we can say f of 3. So f of 3, replace the x with the 3, so you get 9 plus 4, 13 in the numerator, and then 9 minus 4, which is 5 in the denominator. So this gives you 2 3/5. Okay, so a little bit more than 2 1/2. So at 3, we're going to graph it approximately a little bit past 2 1/2. I mean, you can't really tell the difference between 2 1/2 and 2 and 2.6 right there. We know that this is an even function, so automatically at negative 3, we're going to go at 2 3/5, right there. And with those 2 points is all we need to draw our branches over here on the right side towards the asymptote, and on the left side. Okay? Alright, so this is number 3. And I'm going to factor the denominator, x plus 1, x minus 1. The domain part got cut off from the copy, I don't know how, so I'm just going to add it up here, the domain. And so that means all x such that x does not equal, plus or minus 1. Okay, so that's your domain. This one has no holes because it has no common factors in the numerator denominator that cancel. X-intercept is 0, 0. And remember, if the x-intercept is 0, 0, then the y-intercept has to be 0, 0. There's no other option. That's just what it is. Because there could only be one y-intercept, right, at most. And so if 0, 0 is the x-intercept, then that means it's automatically the y-intercept. Vertical asymptotes, x equals negative 1, x equals 1. This one is a bottom-heavy function, so y equals 0. And for symmetry, when you replace the x with a negative x and simplify, you get negative x, I'll put it here on this side, over x squared minus 1. So this is actually the opposite of the original function, so this is an odd function. What does that tell me? That it's symmetric with respect to the origin. So if the point xy is on the graph, just a little quick review, then I know that negative x, negative y is also on the graph. Okay? So let's go ahead and draw the asymptotes. Y equals 0. X equals plus or minus 1. So down this way. Okay. And the only point we have is 0, 0. Okay. So with two asymptotes, I know I have my graph is cut up into 3 sections. I'm going to have a piece here, a piece in the middle here, and a piece right here, a curve right here. So I'm going to have 3 curves, okay, in this function. I can, get rid of those dots. I can evaluate like f of 2 to see what I get. So let me go ahead and do that. F of 2, and I'll put it somewhere around here, so I'll put it up in this corner. F of 2, so that gives me 2 over 4 minus 1, because 2 squared is 4, 4 minus 1 is 3. So f of 2 is 2/3. So the point would be approximate, so this is a point, 2/3. So I know automatically, because it's an odd function, that negative 2/3 is on the graph also. Okay, is a point on the graph. So 2/3 approximately right here, and negative 2/3 approximately right there. Okay, with those 2 dots right there, that's all I need to draw each branch. So towards the asymptote and towards the asymptote. Same thing on the other side, towards the asymptote. And they're curves. I know with a stylus it's hard to make the curve sometimes, but it should not be pointy. These should all be curves. Now the middle part, the middle curve, is what I'm going to do is I'm going to say a number between 0 and 1 is 1/2, right? So I'll see what happens with 1/2. F of 1/2. Well, 1/2 is a positive number. It's 1/2 up here. And 1/2 squared is 1/4 minus 1. Well, the only thing I really care about is to know whether this result is going to be a positive or a negative. So this answer is actually going to be a negative answer. Why? Because 1/2 is positive and negative 3/4 is negative. So when I simplify it, my answer is going to be negative. So at f 1/2, I'm going to have a negative result. It's going to go down this way. Remember, this is an odd function. So then negative 1/2 is going to be positive. So when x is negative, I'm going to get a positive result. So it's going to curve up like this. And there's your graph.